Let's look at problem 67 from OpenStax College Physics, Chapter 29. The lifetime of a highly unstable nucleus is 10 to the negative 20th seconds. What is the smallest uncertainty in its decay energy? B. Compare this with the rest energy of an electron. So let's write down our knowns and unknowns. The lifetime of the unstable nucleus is delta T is 10 to the negative 20th seconds. And that's all that we are told. And then in part A, we're looking for the smallest uncertainty in its energy. So we want delta E. And in part B, we want to compare this value with the rest energy of an electron. So rest energy is E naught of the electron. So these are the two quantities we're looking for. So this is an example of a Heisenberg uncertainty principle problem where we're looking not at the delta P delta X, but at delta E delta T. So Heisenberg's uncertainty principle says that delta E delta T is greater than or equal to h over 4 pi. So that means that delta E is going to be greater than or equal to h over 4 pi delta T. So when we solve for delta E, it's going to be greater than or equal to 6.63 times 10 to the negative 34th joules seconds divided by 4 pi times delta T, which is 10 to the negative 20th seconds. And when we plug in these numbers, we get 5.28 times 10 to the negative 15 joules. In part B, we have to compare this value with the rest energy of an electron. So the rest energy, E naught of the electron, is mass of the electron times c squared. Mass of the electron is not given, but we can find it in a table. It's 9.11 times 10 to the negative 31 kilograms, and c is the speed of light, 3 times 10 to the 8th meters per second, and that's quantity squared. So the rest energy of the electron then will be 8.2 times 10 to the negative 14 joules. So we see that the energy, the uncertainty in energy for this unstable particle, unstable nucleus, is an order of magnitude roughly smaller than the rest energy of the electron.